Okay, so this will be my second model specification, and so for this one I'm just going to run a simple regression with the first dimension nominate score. And so let me put this one in here, and again we're just going to go back, we're going to go analyze, regression, linear. I'll reset this again. Let's go down and do our dependent variable. Our dependent variable is going to be our vote score. Our independent variable, I'm going to use the inverted nominate score because liberals supported my campaign finance reform more than conservatives. I want to get that positive parameter. Up here, statistics, estimates, model fit, all that stuff is good. Should be fine. Plots, I'm going to do the same plots that I did before. I'm going to do the standardized residuals on the y-axis, the dependent variable on the x-axis. I'm going to click the histogram, and I'm not worried about anything else. I'm going to save the residual values, the standardized residual value, and again that'll be saved out there in that last out there in my stata file. I'm going to click OK, and that should get me what I need. All right, so here's the second one. Notice the dependent variable is still the vote score, but my independent variable is DW nominate 1 negative values. Right here, I've got an adjusted R-square of 0.83. Back to my first R-square. So I was able to explain 0.79% for just a party identification. So 79% of the variance in my dependent variable I could explain with party identification. Now going to a continuous variable, I should get an improvement of that, usually about 1 or 2%. And that's what I pretty much find in the second one. So down here, if I go, I'm about 0.84. So 0.79 to 0.84. The ideology provides a little bit better explanation for us, and so it's not sizable, but when you get to the very tail end, when you're starting from 79 and going to 85, that margin is really big. It gets bigger as you get to the higher ends of the scale there. So generally speaking, ideology does probably perform a little bit better. If we look at it, we still got the same degrees of freedom, 432. Our model as a whole, the F statistic is significant, so that means our model specification as a whole is significant. Nominate score, very big beta parameter. Standard error is very small. The beta is, don't worry about the beta. The t-score is 46, and so it's highly significant. That allows us to reject the null hypothesis that that ideology is not related to support for the bipartisan campaign finance reform, so we can create support for the alternative hypothesis that it is related to it. Right? If we go and we look at the residual statistics, note the residual has a mean value of 0, has a standard value of residual, standard mean value of 0, so that's working properly. Notice here we've got kind of more, that continuous variable does a lot better in doing normal distributions, right? But we still have a little bit of tail activity. So when we run this, it still may not be normal, but obviously it's better. If we look at the dependent variable versus the other one, notice the clumping that we still have here. We don't have a lot of kind of mixture in the middle, and notice here we have kind of some clumping here, and this is because we had only 10-15 votes, right? And so we get kind of we get some clumping or those lines in there on the basis of the values. But notice here we have some kind of outliers, a little bit of heteroscedasticity in it because we got some clumping up here, but generally it's better than the other one. We'll see. Let's go look at the actual results. Notice what it did. So ZRE1 is from the first model, ZRE2 is from the second model. Let me run the correlations. Analyze, correlate. I'm going to do some bivariate correlations. I'm going to reset this. So I want to do my second model has this value, and I'm going to use the second residual score, and I'll run the correlation for that. When I run that, I get a Pearson correlation coefficient of 0.00 for between the standardized residual and my independent variable. The model cleanly separated the variance associated with my independent variable from the residual term, and so that's good. That meets up. Let's run the descriptive statistics and explore. And I'm going to get rid of this residual. Remember, the first one goes for the first model. Let's do this one. I'm going to do here, I don't want any of those, but I want the normal probability plots. Click OK. And notice here, it still tells me it's not quite normal. But notice we get a little bit better fit here when we go through. We get some kind of curvilinear stuff, but it's closer along the lines there. And we get one big kind of loop through here. But we probably need to include some other models to get a purely, you're never going to get really truly heteroscedastic results with only one independent variable. You often need 3, 4, 5 independent variables to really kind of separate all the variance out and get the systematic relationships out. But generally speaking, it's a pretty good model. Okay. Good. We got some heteroscedasticity in it and some other things. We couldn't be completely confident in these results, and we'd need to work on it some more. But we can draw some quick inferences on it. Okay, good. I'm going to run one more. I'm going to do one more lesson, and that's going to be for the third model. And the third model, what we'll do is we'll put in both of those independent variables, the first and second dimension scores. So shut this down, and I'll start over in just a minute.